Hi, this is Liz Presley with Tutor of Dragons. Today we're going to use our calculator to find rotations and integrals in calculus. You have two different types of rotations. One is a disk, one is a washer. A washer is where you are not on the boundary. You're rotating about another line that would be away from the boundary, leaving what we would call a hole or a void. When you are using the disk method, you are rotating on the boundary. For instance, I might give you y equals square root of 2 square root of x plus 1, and I'm going to rotate this on the x-axis, okay, which was essentially y equals 0. So if I were to quickly graph this, I know that 2x plus 1 is above that. I always try to put the top equation in the y1 and the bottom equation in the y2. So this would be 2 square root x, get out of my square root, plus 1, and I am going to go ahead and put the 0 there. Now, the thing is these will not intersect, so I need to know bounds of where I want to rotate. So I want to know what the rotation would be from, say, 0 to 3. Okay, that would be my interval for my rotation. So I graph it, and there we go. So I'm going to rotate from here to here. So if I were to quickly draw it this way, it'd look like this. And down here, so this is in essence what my rotation would look like. So it's kind of make this igloo, for lack of a better term. So how do I do this? I'm going to use the equation pi capital R squared dx, because I am using a top minus the bottom. My r in this case is top minus bottom. So calculator, go back to my main screen, and I'm going to do pi math 9, and the rotation here, my interval is 0 to 3, so the x on the left is 0, the x on the right is 3, and again I'm doing this r squared, so I need to insert an extra parenthesis, alpha trace y1 minus alpha trace y2. Now, do I really need to do that y2 because it's 0? No, but I am all about the discipline, so I'd rather you just be in the habit of always doing y2 minus y1. We need to square that, and as I said, that's a dx. Hit enter, and my rotation volume would be 109.5, okay? Now, for a washer, I'm going to do something a little bit different. Instead of using this, I'm going to, so we'll clear all that, go back to here. I'm going to use the equation, clear, negative x squared plus 4. And I'm going to use 2x plus 1. So those are those equations, okay? So they intersect at negative 3, negative 5. And again, at 1, 3, those equations are negative x squared plus 4 and 2x plus 1, okay? I want to rotate this about the line of y equals 5. So if I were to draw it quickly, now forgive my drawing skills, my dad and my daughter are the artist, I'm rotating it about this line. So you can see I'm going to actually have a rotation up here that would create this rotation, okay? So it becomes this weird thing with this unique kind of hyperbola cut out of the middle of it, this weird shape. So if I were to draw it this way, it'd look like that, okay? That's my volume if I were to rotate it that way. So, and we've seen some of these buildings. In St. Louis, the planetarium looks like that. So anyway, how do we do this? So we need to find the R. The big R is the entire thing. So that would be from the line of y equals 5 all the way down to my linear equation here. So R is going to be y equals 5 minus y equals 2x plus 1. Now my little r is what I call, oops, the little r is right here, is what I call the void, okay? So remember back in geometry a long, long time ago, you would be given a square and you'd have to go find the shaded area. And you would do the whole thing, which is your r, minus the void, which in this case is the little r as it relates to the calculus. And so my little r, my void, is in this case 5 minus that parabola of parentheses, negative x squared plus 4. If you were doing it by hand, you would distribute that negative and get 5 plus x squared minus 4, which would end up being x squared plus 1. That is your little r. But we are using the calculator today, so I don't need to do that. But I do need to put in 5 here. Now, so I need to remember that 5 is going to be my y3. I need to know that my negative x squared is my y1. I need to know that the 2x plus 1 is my y2. So if I were to write my equation, pi r squared minus little r squared from the x on the left to the x on the right, dx, this is going to become pi. The x on the left was negative 3. The x on the right is 1. Now remember, my big R was my y3 minus my y2 squared minus my little r was my y3 minus my y1 squared dx. Now, when you're actually doing this in class, do you need to write this all out? Probably not. But if you're doing a lot of these for homeworks, to me, this helps me keep it straight, especially when they're out of order here. Okay, so you can see there's that y5. R, big R, the whole thing, little r is the void. So how do we go write this? Second quit, pi. Now, if I'd forgotten my pi at first, it's no big deal. You can always do the integral and then put it at the end. Or let's say, let's try it. Math 9, negative 3, 1, parentheses open, y3 minus y1. Close parentheses squared. I like using the squared button because it makes it go much faster, okay? Minus my little r squared, so parentheses, alpha trace y3 minus y1. Nope, I did that one backwards. Okay, close parentheses squared. So notice that I didn't read my own handwriting, so I need to go back and rewrite over that. So I just arrow over to that. I do not need to delete. I can just go to my y2 and write over it magically. And then I go, oh my gosh, I forgot my pi. Silly Liz. So there is this second insert button. So you can do second insert. My pi is right here. Again, it's in blue, so second pi. And magically, it just goes there. All the way to my end, dx. Boom. So there's my volume, 294.891. Thank you for watching. If you like this video and want to receive more, please subscribe to Tutor of Dragons. Have a great day.